Hey guys, sorry, I am not in lab again today. You can definitely do this lab all on your own. In fact, it was even designed to be done on your own. So we're going to be doing a virtual lab for stream erosion. It'd be great if we could go somewhere and observe this outside, go somewhere else, observe some other changes, but we can't. So we're going to have to do our best with the simulation that I have provided here for you today. So this is the actual lab. So you'll see that there are directions. It says go to the Water Erosion and Deposition virtual website. You can either follow this QR code if you're going to do it on your phone, or I posted this link on our Teams page for lab. So you can go click that and get there on your computer. I will say I think it's a little easier to do this on your computer because you can see it a little bit better, but your phone will work too. So moving on, so it says follow the directions posted on the virtual lab and complete the table below. So we're going to start off with the problem. So in science, there's all sorts of problems, and that's what scientists always work to find a solution to these problems. So the problem we're going with today is how does the slope of the land, amount of vegetation, and the amount of rain affect runoff erosion? So just a little bit of background, you already know most of this stuff. It says when it rains, the water falling to earth will do one of three things. When it hits the ground, it can evaporate back into the atmosphere, infiltrate, which means to soak into the ground, or run off into nearby rivers and lakes. Runoff is affected by the slope of the land, the amount of vegetation, and the amount of rain. So hopefully you already kind of knew some of that stuff. And now we're going to make a hypothesis. And I know you always say a hypothesis is an educated guess. Well, an educated guess about what? It's really a solution to the problem, which is, yes, an educated guess for the solution. So really what I want you writing in this hypothesis is your educated guess to the answer to this problem. So here is going to be, you're going to start it off with, I think. I'll give you a hint. And your hypothesis will be, how does the slope of the land and the amount of vegetation affect the amount of rain affect the amount of runoff erosion? So again, you're just answering that here in the hypothesis section. The next thing we're going to do is once you get to the animation by the website, what we're going to be doing is changing the slope and or the amount of vegetation and the amount of rainfall, and I'll show you how to do that. In fact, let's go there now. So I believe I already have it pulled up. Yep. Okay, so this is the animation here that you're going to be adjusting. So right now it's set at a 10-degree slope. You can change that by hitting right here, this little black dot on the end of the angle. So 10% slope, you can see this hill there's a hill, but it's not super steep. And if I change it, you can see that slope, I gotta hit it just right apparently. Oh, I think I have to reset it from the last time. There we go. Here's what a 30% angle will look like. So by the way, after you hit rain, you do always have to hit the reset button to change stuff again, just like I just had to. So you can see a 30-degree angle is a pretty steep hill. So we have the hill. Right now it's got all sorts of different vegetation and a little river here at the bottom of the hill. So again, you can have a 10 or a 30-degree slope. So we'll start off with a 10-degree slope. You can see I can have vegetation or no vegetation. So I'm going to go back to vegetation, and I can make the rain low or high. So right now you should notice we got some storm clouds, but when I hit high, we got a big storm rolling in. So you guys kind of know from being alive for the past 15 to 16 years, when you got dark clouds like this, it's going to be a bad rainstorm. Before you actually hit the rain button to simulate what's going to happen, I do want you to make a prediction. So in this prediction, you're going to, again, it is a guess. It's a guess based on the future, of how much sediments are going to end up in that river. And you're just going to tell me, do you think it's going to be high, medium, or a low amount of sediment? So you can make your guess right here in this column. Next, you're going to move on to you're gonna actually go ahead and do the simulation. So I'm gonna go back to there and show you. So now again, with that first box in the table, it says we're gonna have a 10% slope. We do want vegetation, and we want a low rainfall for the first one. So I'm gonna go ahead and make it rain. Now it's stopped. You should be noticing that the river got darker. Hopefully you realize that the river is now full of sediments. So how much sediments? We're gonna grab our beaker. So to do this, you point at here, you click down on either your mouse or push down on your phone, and you drag it up here. It'll tip over and it'll show you how much. So you can see that the relative amount of sediments, now relative just means compared to everything else, this is a low amount of sediment. So it's in the low range. So you'll fill that in on your chart. So for the first one, it should be low. You had already made your prediction, so you could now see if your prediction was right or wrong. But then we want an actual, and it tells you on the chart, it says the number of lines in the beaker. So this goes to the 1, 2 beaker, to the 2 line on the beaker, sorry. So you fill that in on the chart. So you will have already had your prediction, and now you've done the relative and the actual measurements. So then you'll go on to the next one. You do have to hit the reset button. Again, anytime you make it rain, you got to hit the reset button. So you'll change in that next one. You keep the slope at 10. You change, this time we want to keep the vegetation still and move on to high. You're going to make it rain and go ahead and do the fill in the chart. You're going to do that for the rest of the chart. Shouldn't take you very long. Once you're done with that, you're going to flip over. There's 2 post-lab questions here. I do realize I did not give you much space to write, but you can use any of this space to answer your second question. With these, there are multiple right answers. The key is that you do need to explain your answers for each one of these to make sure you get full credit for this. Afterwards, you're going to go on and do the post-lab Regents review questions. My students, I do want to remind you, actually, I think Mr. Migos, this won't hurt either, but mass movement, that is another word for gravity erosion. So gravity erosion is also called mass movement. Other than that, this lab, you should have no problem finishing it up today. Once you do the table, just a bunch of questions. There are, There are 19 questions, so it might take you a little bit. I will also give you Friday to finish this up if you have any questions. So hopefully that makes sense, and you can message me on Teams if you do have any questions. All right, guys, good luck.